let's see what's next up on the list. I know I got a couple big bass units I got to work on. Hello, gents. Mr. David Turner. Ah, it's your time, my man. Oh. Hold on a second, guys. He's got his information on that side of the amp. And it's on this side of the amp. Okay. Okay. Woo. All right. Oh, packing tape. Why do guys use don't use packing tape, you guys? It's a mess. Okay. It's an X-Force base, is all we know. Because that's all it says on the front. Old school Carl built. Means we're gonna have quality components in here like Toshiba's and that kind of deal. So normally it's like 1200 or 1100 or 13, whatever, and a whole bunch of other digits. But let's get the case off this and see what we find. Okay, so I want to point out that there was a screw missing here and another one down here in this back corner over here. Oh yeah, old school. That's one. That's two. No. Oh. Oh, we got some burnt resistor. There's three. Okay. So I got a voltage regulator for every single one of the two fan banks, which is good. Okay, now we all know from past YouTube VJs that what we have going on here. Oh wow. See, this is the way things used to be built. I mean, this is good stuff. This is iron core transformers that were wound on a machine that come out of some backcountry place. I know the whole story behind the machine too. It's good stuff. Now we've got a fried combiner resistor here and a fried combiner resistor here, and it looks like this has gone bad multiple times. We can tell by how many times this one resistor has been changed. Let's, gosh darn, look at that. Let me zip on in here. And let's get our white balance set. So we've got ourselves a mess basically. And what we're looking at is how hot the solder's gotten down around the transistors all throughout this whole thing. This thing has been apart many times. It looks like the pills have been out many, many times. So we know we have an imbalance here in this section for whatever reason. I mean, all these caps have been unsoldered. All these pills have been out. I mean, you got shit down in here that's not even soldered down right. These little discs, I mean, look at this. This thing is just flopping around. There's arc burns on the transformer. There's arc burns up here on the transformer banging against the transformer, the combiner banging against the output transformer. This is bad. Okay. So what caused our failure? Is it all this bad solder work? Is it the capacitors? I gotta think in a wider field of view, guys. I gotta take you out of the close-up deal. We gotta think, is it something wrong with one of our output swamping capacitors, like this one that's bent down? Do we think maybe that this disc capacitor's gone bad and they've just chased the pills a million times? I don't know how well the camera's gonna pick this up. See if I make it brighter. Okay, so we're looking at the two different colors of copper. So we got the nice lighter copper, and this isn't shadow, this is actually a color that the copper has gotten darker, and it's right underneath the heatsink, the whole length, all the way down to here. Now what we have found that helps a little in these little designs, this old school stuff, is we take and we block off this vent and we block off this vent, and then we create a channel so just the air for the whole cabinet goes down and exhausts out through over here. We found that helps a little bit. Now, all right. When I say it helps a little bit, is right now as it stands, most of the air goes in this box, it kind of wafts over the components, and then it runs out these back slots in the back. It's going to run out over the vent back here. It's going to run out of this vent here, and very little air actually makes it down this path. So I started blocking these off 10 years ago. Yeah, I've been in business now for almost 10 years, you guys. 9 years and like 6 months. I've been working on these ever since I opened the doors. There's a couple things that we like to change. We probably won't change it on this because they are working. I hope they're working. We're going to test them. Is these 50 amp bridges that make up the rectifying circuit. It's got good electrolytic filtrations going on here. But we have to change how the air flows through the cabinet. And we got all 6 of those fans pushing air in. And air is like water. It's just going to take the path of least resistance. So air is going to run out of here. It's going to run out of this vent. And maybe a little tiny bit's going to kind of, and then blow out this vent in the back. Maybe. If we block this off, create a channel, which means I got to pull this whole board up, which is no small feat. Pull this whole board up, take a piece of phenolic, hook it to the heatsink. We're going to put a block here across this one rib that's open. Then we're going to block off that rib that's open and all 3 of these vents here in the back. It'll push more air through. This is the back of it, looks like. So what we're talking about is we're going to utilize this much exhaust port and only 2 ribs, and then half that rib we're going to block it up with this, or half of this vent. Only utilizing half this vent, about this much of the vent. And then we're going to limit it down to even these 2 slots. So what I like to do is I'll pull this slot out, this rib, which will open it up, give us a little bit more exhaust. It's a lot of stuff to have shit get cooled with a long path of air exhaust, a long exhaust path for the air to come out of the deck. There's still a heating issue that takes place with this thing. Right, this is a slow cruising 2x8. Okay, you got to take it easy. You're not going to get unlimited talk time out of this. We can make it better. Like, we'll block off this vent here. And we're going to block off some of this vent here. But we have to leave some of this open, otherwise there's too much back pressure in the cabinet. So we're going to help increase the airflow. But you know, there's part of me that wants to take a piece of copper and come off the heatsink and then bend the copper flap around on the inside so that we can utilize this whole vent and this whole vent to help get air out. What I've done in the past is just bring the board right off the bottom of the heatsink, bring it right up to the slots, but then we're just limited to this tiny little space, and we need more low pressure space on the back side of the heatsink. So we're going to play with that. But man, this thing has just been soldered on and soldered on and soldered on. Look at this. So we got to clean all this up. We got to fix all of these. And it could be that one of these disc capacitors has gone open from being pulled out of here so many times. We could have a flick of schmoo laying down here. We've got a transistor here that's completely come unsoldered. And look at that. The tab's not even hooked up. Let me grab a sharp pointy device. Look at this. That tab's not even hooked up. This isn't too bad. I've seen way worse. I'm not going to lie. But a lot of this, the grayness of the solder, this is from overheating. Like down in here. Yeah, this is, the transistors have been in and out a bunch, but this is from, please note this has been shipped here, bounced around in shipping, sat here and got moved around a dozen times, and there's still pieces of shit floating around inside the amp like this in the pill area. So let's rip it apart. I'm going to call the customer and tell him what I found. Okay. So all I have done so far, every time I look around I find more solder flick. Okay, so the only thing I've done so far is I pulled all those chomed resistors out of here. We got to make this look all good again. But I took this resistor off of this combiner. This son of a gun's cracked. So I got to completely rebuild this combiner. It's no big deal. Man, I mean, it's plumb split cleaning too. This will never work. Anywho, this one looks okay. I got to clean all the solder work up on it. And then I pulled all the blobs of solder off the combiner resistor over here, the final combiner resistor. So, but broken combiner, transistors that aren't soldered in. Ugh, messy. And the more I look at this, the more shit I see sitting in here. I mean, how big is this pile of shmoo going to get over here in the corner? This is all the little hunks of stuff that I've dug out of this thing just so far, that were just in here floating around. Just randomly could blow your amplifier up at any time. Got some 10 ohmers that need to get checked. Probably just going to end up replacing most of them anyhow. That way I'd rather replace with new that's tested than take the risk of running something old that might be bad. Just off of visual inspection is not enough. So, okay, I'm going to start pulling the pills out, starting from this end, and that is what is that? An IF, an IA, and it wouldn't surprise me as I take these apart, the lids pop off. IA, okay, IA, an OA, that one's an OA, 1A, or IA, and then an 8K and a 9B on the 2290s. So, all right, we're going to start down here. On this end, we're just going to take them off, lay them down on a paper towel, and we're just going to go this direction with them. So let's see what we got to work with. Okay, so we got all the pills out of this thing. Let's zoom on in here and let's take a look. There's one thing that I can pull away from this entire segment. There's not a lick of thermal paste anywhere underneath any of these 10 transistors. This is bold dry. Look at this, you guys. Bold dry. Well, we got the pills pulled out, and I got them sitting over here on a piece of paper. Let's go check them out. So these are the same order that they came out in. This is an IF. This transistor here is IF. Come on, there it is. Okay. Then here's the 1As. It's the same parts. No thermal compound. Solder on the bottom of the transistors. Schmuck and fucking crap on the bottom of the transistors here. Crap on the bottom of the transistors here. Crap on the bottom of the transistor here. crap all underneath this transistor here. So, okay, we know there's no thermal compound. We know that these transistors have had a hard, hot life. That's all right. We'll get them all cleaned up. Let's just see how many we got that are good or bad. Gain of 54. That's good. This one's got a solder flick on it that goes to the foot. Okay. Okay. And before these go back in, of course, I'll wash them and clean them all up and straighten the tabs out and all that kind of stuff. Gain of 57. That's good. These can be matched up together. These two were matched together. They can stay matched together. It's really surprised none of the tops came off the transistors and taken them out. Gain of 51. Of course, it's pretty delicate with them. And the gains on these transistors are really high, which is encouraging. Nothing short and nothing out. Gain of 54. Those are close enough to live in the same universe for now and ever and more. All right, so now we're getting down to the section that had something wrong with it. We don't know if the pills or whatnot. I believe this is the one that wasn't even soldered in. It's bad. So that one is bad. So much bad solder work. Gain of 39. That's encouraging. Testing, and the survey says, oh, 33. Cool. Cool. Very cool. Doesn't look too awful horrible, but it is horrible as hell. These legs are all torn up. Gain of 52. Okay, so these can be paired together. And this has a gain of 52. One bad transistor in the final section, which is going to make the customer's day. Let's check out our drivers. Got no thermal compound. Unbelievable. Gain of 23, which is cool. Gain of 22. These are matched. Okay, so I got to find a used transistor. It's got a gain of in the 50, 55, somewhere in there to match up with this one. This one is toast. Toast. All right, we know what we're working with. So I gave it a bath, and I got the little dregs of solder paste that was in here. I mean, like a fart and a wisp of it. I got it out of here. So now I got to go around with a dental pick. I got to clean all the schmuck and the dreck out of here. each one of these pill pockets. And then I'll go through with a Q-tip. I mean, this is the stuff I never show on camera because you guys don't want to see this. This stuff is lame as gets. I'll go through and I pick around all the edges. Because all it takes is one little gerbil of just one little tiny piece of metal like that here. It's all it takes, and then the transistor can't sit flat no more on the heatsink. So I'll get all this stuff cleaned out. I'm going to go back with a Q-tip and really get into it. Fun, right? I called my customer. I started BSing with him. And the next thing I know, I told him, I said, man, well, we've been on the phone. I cleaned out all these pill pockets. I straightened out all the legs on all the transistors. Cleaned all the transistors. Made sure everything was nice and flat. Reflowed all the solder. Replaced all the 10 ohm resistors. Yeah, these are all brand new 10 ohm resistors. They're all matched, they're within 1%. Not that it makes that much of a difference, because it doesn't. I said I reinstalled all your transistors with thermal compound underneath them. Mind you, it's better than what it was when it came in. They didn't even have thermal compound underneath them. We did have one little flaw that happened as I was straightening out the legs of the transistors. Let me show you what I mean. Let's come over here for a minute. We'll zoom this out. So when you pull the transistors out, they look like this. Legs are all coned up, usually overloaded with solder. There's usually a little fold in them here and there. So you got it before you go and reinstall them back into the amp. You go and you'll knock all the solder off all the legs, solder socket, solder wicket, whatever, flick it, tick it, whatever it takes. Then you go with a toothbrush. That's the reason my fingers are so gross. You go with a toothbrush and then electronic wash and go all the way around the edge and clean all this up. Then you come back and we're going to clean all the schmutz, this stuff. So this is the stuff that causes pills to burn up. This little nurble of shit that you can just take off with your finger. This is garbage that was down in the pill pocket. So you clean the whole bottom of the transistor off. And I had this one in my fingers and I'd straightened out the legs of it. I had it in my fingers like this, and I'm like, so they're going with a paintbrush, cleaning it off. See, you get it all nice and clean. I hadn't scraped the bottom of this one off yet. And the top just went blink. Now this transistor is still good, technically, ish, sorta. This had a gain of 59 on it. Now it's got a gain of 4. Now, I don't care. I've got the epoxy, the supposed epoxy, not taking myself too seriously. Oh, I've got the only penis schmack, schmicklick. No. I've got epoxy that is in theory rated for this temperature. You don't use super glue. Super glue is too thin, it migrates and it goes down here and gets inside the legs of the transistor and kills it. So there's a special type of high temp epoxy that you can use. I don't have the bottle handy. I should have gotten it before I started this clip. Anyhow, I could put a couple little dabs on it, placed just in 4 spots, and then you go and apply the lid to the top of the transistor. I got a special tool for that. It sets it on there. And then you kind of put this in like a little rubberized vise and let it sit for about 4 or 5 hours. But because I was in the process of cleaning it with a toothbrush, the electronic wash and some of the thermal compound and schmoo came off the brush and went down inside. You could see it. It had two little white shiny spots on it. So I'm all, I put it on a gain checker, and now it's got a gain of like 2 or 3. So I can't put it back in the box because it was paired with a transistor that had a beta gain of a bunch, right? So let's say this is the one that we toasted. This is the one that fell apart. So to give us the best chance of success, I took 2 used, but they both had gains of 74 on them, red dots, and put them down here at the end. The reason I did that is because they have the highest beta gain. Well, that arguably is going to be the hottest point in the whole amp. If we think about how this works, air is going to flow in from this side, and it's going to get saturated with energy, heat. So this is technically the hottest portion of the box, is right here before it runs out the back of the cabinet. So I was bullshitting with him, just kept on working. I thought, well, I'll make it up in the video. I'll explain what happened here as soon as I get back in the next segment. So this is our combiner that's cracked. It's cracked this way, and it's cracked this way. I mean, like super cracked this direction, hyper cracked that direction. So I'm going to unwind this and build up a new one. I'm still trying to understand, other than the transistor not being soldered down. Oh yeah, I lifted all these up and tested each one of the output. We're fine. I want to check these disc capacitors. These orange ones don't have a tendency to fail that often, but it does happen. So I want to make sure that these are still 150s. That's what the 150J stands for. That's right there, 150J. It's supposed to be about 150 puff. If these are even remotely low, I'm going to pull this one out of the circuit, and we're going to replace it with metal clad, so I never have to worry about it again. You think about how much heat's present right here. I mean, look at the discolorization in the board, right? How much heat is present here. Then the amount of current that's flowing by that. The transistor's taking all kinds of a beating. So I'm thinking maybe this one broke down a little bit, because something in here failed at some point or another. Either a transistor went bad or something, but we don't know, because the guy that owns this amp was the second owner of it. And when he bought the amp from the guy that he bought it from, the guy never bothered to volunteer what actually happened in here. He just said, oh no, it just needs a couple little things fixed. So, long story short, checked all the 330 puffers, checked all the 1000s. Now we're going to check these, our output 150s. Just takes a minute. Just takes a minute. I'd rather be 100% sure than guess than key down and burn up more transistors, especially at, you know, $200 a piece. So there you go. I got to check this one yet, and I want to check this cap here, but I'm pretty sure we're good here. This hardly ever never fails. This cap sometimes does break down though. I want to go wash this again, get what little flux that I've now put in here, but this is 1,000 times prettier than what was in here when we started. It looked like a chicken had gone bagak poop, bagak poop, bagak poop on all of these pills. So we're in a way better place, way better place. We're not even done yet. God, I got to talking, and right now I'm playing a video live. There's a camera up here for the guys on Paltalk. That's what this is up here for, this camera right here. You got to collide with the guys on Paltalk. I'm just over here working. I'm like, man, I better come back and give my guy an update on where we're at. Okay, so where we were at when we left off is we just had the pills in it, and we'd redone all the solder work in it. So now we got a whole new power distribution network in it. One thing I had to change, which was an absolute must, is they had all the power wire coming off of both of these buses over here, off this one bus. They had all of it, well, these two buses coming off of this over here. They had it all tied in down here at the end of the lead, down here. So now you think about what that does with amperage and the current that's available for the transistors to drink from. Put all your power in down here. So you got these two transistors drinking, these two transistors drinking, these two transistors drinking, these two. It's like a big long extension cord, but for DC. And there could be like a 1.5 volt difference between here and here. So what I did is I took the power wires, instead of having them tied in here, I pushed it over one so it could feed the 2-pil and kick a little bit of voltage to these two sections. Then I kicked this one down to help kick that voltage up down here at the end of the rail, make it a little bit more even. But I could not bring myself to reuse these. I couldn't do it. I mean, come on now, really? Come on, it's me. So I don't keep a lot of these in stock. I've got maybe 100 or so little 2 waters. In the flyback position, the 5 watts don't pick you up any watts for sure. The 5 watts actually don't do anything for you until you have an imbalance. But yeah, let's get in here and let's look at this. So now if you guys can remember where we started from, what this looked like, it looked like 2 chickens got in a cockfight with a rooster inside of the barn, and there was poop scattered every which direction. It was chicken poo everywhere. Now everything's nice and soldered down, smooth, clean. Got thermal compound underneath everything. Now we're looking right and we're tight. It's about the only thing we got left that we got to do here. Hold on. Okay, about the only thing we got left to do here is we got to pull all these screws out down the length of this side. There's like this screw here, and I think there's one more that's over here underneath this tuning tube, which we got to bring up anyhow when we do our final tune. And I got to pull all these switches out of the front. So I got to disconnect the power switch, the sideband switch, and the variable power. Slide all that back in, and then I got to take my big fat hand, slide it up underneath the heatsink. So I might actually undo the power leads too. Slide my hand up around the heatsink, and I got to stick to the back side of the heatsink a piece of copper that we're going to take and we're going to bow out and bring over to this back vent. Like we were talking about in the previous segment, what I want to do is I want to capitalize on using the surface area between these 2 vents. So we're going to block off this vent down here. We're going to try and make it so the air can get sandwiched and go through the heatsink, but then it's got to have more surface area to come out. So then we'll get the whole board to lay back down again. And then I'll come along and I'll put phenolic along this top strip. Also, what I got to do is I got to cut this out, cut this rib out, cut this rib out, and then I got to file that down flat. So we have the least amount of air restriction with air coming out. We're already asking a lot. The sandwiching the air out of them 6 120 millimeter fans. And then we put all this shit in front of it. All this coax and the switches and everything. That's all dragged to the air. Think about it. Air comes in, tumbles around inside the cabinet, flows, and then it's got to go down underneath and come out. Look at all this stuff stacked in front of it. I mean, why couldn't we put the switches over here? That was always my idea with this cabinet. Move this here, get rid of this vent over here, cut this vent in half. Small little critiques. I probably would have set this up, like raised the board up so it's above this 3rd opening, so we'd have even more air for the air to flow underneath the heatsink and through it at the same time. But without doing a massive redesign on this thing, there's no way for us to achieve that. So out come all the switches. Out comes the power wire. We're going to have to release this bung. Might even have to pull the breaker out of it. Got to disconnect the coax connectors on the back. Shimmy this up, forward, and then I can get inside and bing, put a little piece of copper in here to shuffle the air underneath. So I'll have it does this, so the air can tumble out of the heatsink and use both of these vents instead of just being pinhole trapped to come out of here. And even at that, we've only got a slot and a quarter that the air can come through. So let's open this up. Let's channel the air in the right direction. Okay, so this is what I was talking about. In the old school boxes, they used old stock pieces of heatsink, just little chunks of it, to help support the board. There's a screw that goes through here that goes down to the cabinet that holds this down. Then the board gets screwed down here to these holes. But what we're trying to do is, let me back it up a little bit more. What we're trying to do is reduce the back pressure. So what we've seen over the years with X-Force is all of a sudden the heat sinks were only this wide. And then we've seen the heat sinks were only this wide. Then we've seen the heat sinks were only this wide. So this old school box like this, it's got a full nice wide run on it. of heatsink stock runs almost the way to the back of the cabinet. Now, you don't want to run the heatsink all the way to the edge of the cabinet. There's no place for the air to recollimate. There's a lot of drag that takes place as the air is going through. And to help it pick up velocity, you want to create a low pressure at this back end of the cabinet. But then we're going to run that right into this grill system. So you've got all the total surface area that the air can pass through here, and then you're going to run it right up against like 3 little slots. That's no good. So to help pick up and decrease the back pressure, we stretch out the surface area across these 2 vents. So this one and that one. And how we tie those 2 vents together is we just take some 30 thousandths thick copper. We just attach it with some VHB double-sided high temp stick tape. Never going to come off. I mean, if you're able to get this heatsink hot enough to get this heatsink or this double-sided tape that breaks down at like 270 degrees, if you can get this tape to come loose, you've got other problems. You got shit coming unsoldered. Transistor's going to be blowing anyhow. So this is more than up to snuff to be able to hold this to the heatsink. Whoa, whoa, hey, I'm talking with my hands now, gosh darn it. It's more than up to snuff to hold this up against the heatsink. So it blocks off effectively this whole area, which we don't need air moving down anyhow. It's going to force all the air for the whole amp through the heatsink path, and then it increases the exhaust area. So it's going to go from here to the end of that second vent, and then we'll knock that rib out. But I wanted you guys to see this. So we got a nice little square end here that sits up perfectly smooth against the heatsink. See that? We don't have to have an airtight seal, but we want to create enough of a restriction that it's going to really motivate the air for the cabinet to go through here. Hopefully that'll pull more heat out of this thing. I'm pretty sure it will. So, yeah. This is the transformer side of things. And let's just pan over here. And that's the heat exhaust side of things. Now, there's going to be people out there like, well, he forgot to sand this down. Why do you do such crude craftsmanship? No, that's the very end of the copper plate that's right here. It's technically the end of the hole. So if I was to file this down, then I'd have an opening into the inside of the cabinet. We don't want that. That'd be bad. So I went ahead and I nipped this bar out, and then I sanded it. I took a file and filed it down. So just picture this versus that. Which do you think is going to let more air flow through? Yet another flat surface that we've got to drag the air molecules around and over and through, or just straight out. So we're going to utilize both of these ports versus just the one port. That makes sense? That's a lot less resistance. A whole lot more air gets to come out of there. So, I mean, this is up against a wall. Nobody's ever going to see it. This looks really clean and neat. I mean, it's all sanded down nice and square and clean. I swear I see some of these things, they show up and it just looks like somebody took wire dikes and cut them. And I'm like, really? You couldn't just take another 30 seconds with a file and square that edge up? Now this fin here, which is open to the upper deck, went in and I blocked this off with 2 pieces of phenolic. And I put the whole internal guts back together. So right now as it stands, this thing's done. Now I could turn this thing on and test it here in a minute and find out I got some blown rectifiers and a whole bunch of other shit, but I doubt it. I doubt it. But this is where I stopped for tonight. It's 7 o'clock at night. I've been out here since 9 o'clock this morning. I've been totally farting around with this thing for about 6 hours, 7 hours now. It's time for me to call it a night and go and spend some time with the family, but at the end of the day, I think this thing's going to work really good for this guy. So I will see you guys tomorrow, which will be in about 5, 4, 3, 2. Do you ever have one of those days where you're going through the day, and this was my theme of my day yesterday. This guy puts a post up in BBI Amps, the group on Facebook, and he asks a question. Now, I look at the picture that's associated with the question. Believe me, this is all leading somewhere. I look at the picture, my brain looks at the picture, identifies what the part is, and I identify it as a bridge rectifier, submerged, all encapsulated bridge rectifier. And the question is, do you know where I can find these? I read the very first line of the statement, the question. I'm like, oh yeah, I got you. So I come out here, take a picture of the rectifier, boom, drop it on the, everybody's like, oh wow, that was quick. I can't believe you got to it that fast, blah, blah, blah. Something in my brain says, go back and reread that. I go back and I reread it, and he goes on to say, this is from a Fat Boy or X-Force, whatever, motor mall, and this is one of the contactors. I was in a hurry. I identified the part wrong. So I had to go take down all my previous statements and then issue an apology. Hey man, I'm sorry I got that wrong. I did not read the whole thing because I'm an idiot, yo. That happened on 2 or 3 things yesterday. So, I get done with this thing yesterday and I'm all proud. I mean, I'm taking photos of this thing all the way around. And I go to the owner of it and I'm like, what was that scene in Lion King where the father is holding up the baby lion? He's like, this is my son. I'm so proud. The world must bow before it is beautiful, right? That's my attitude I got when I'm going to the owner. Look, I totally undid this train wreck, chicken poo covered mess and turned it into this work of art that'll work forever for you. It's built with way overkill components that are absolutely not completely necessary to make it all work, but this will help it work better for longer if you do have a problem in the future, and it'll make it more efficient. Look at my child. Three minutes later, phone rings. Hey, BBI. I'm like, yeah. He goes, I sent a note in with that. And I'm like, yeah, you did. He goes, did you read the note? And I said, kinda. I opened the note. And I read, needs a lot of TLC for this amp. I found some burnt resistors, some bad transistors, I think. So then I come down here and I skip right over this whole portion of this one sentence here, which I'll read to you here in a minute. Rebuild, upgrade anything, make the fans quieter if possible. So upgrade anything I feel it needs, and upgrade if possible. And I'm wet. I got this. And I tore into this and I spent all day working on it. 3 minutes later, the guy calls me. Did you read the note? And I immediately knew right then, as soon as he said that, I was like, oh. I think the very next sentence, I would like to turn this into a straight 10 pill if possible. I'm not sure if the transformers at 110 volts will support a 10 pill, but I'd like to use Toshiba's depending on how many of these are bad. I read the last statement, and then he goes, basically rebuild just like the Skid Row amp you did with the airflow upgrades. You have the freedom to do anything else you want. BBI badassery. Two, drive an 8. He goes, well, that's not going to be that big of a deal, is it? I was like, no, it's not that big of a deal. It's not. I'm just an idiot, yo. Now look, I'm entitled to a couple mistakes a year. We're halfway through this year. This will be like my 100th one, right? Come on. We're only human, right? So today, this is a fully functional 2x8, but that's not what the customer wants. Today we're going to convert this into a 10 pill, which means input splitter, output splitters need to be replaced. We're probably going to do it so that this transformer, this transformer, this transformer, this transformer need to be rewrapped. This transformer needs to be replaced with this style of transformer. Thank God I just ordered some. Got to add a capacitor here, change the wrap direction here, rewrap this with the right appropriate sized wire, add a cap, add a cap, add a cap, add a cap, add a whole bunch of coax. Take out the 220 290s, put in 2879s, rechange our input network just a wee little bit, and then we'll be off to the races and running. Then we had another whole conversation on the phone, and I want to bring it up because I think this is silly cool, man. So he knows that I'm a hard rockin' son of a gun, right? And he knows that one of the bands that I kind of like is Black Label Society, which I thought was friggin' awesome. How big of a Black Label Society fan am I? 15 years ago, I built myself this. This is an official Black Label Society vest. Today, you can go to, I think it's Red Monkey or whatever it is, Red Monkey Leather or whatever it is, and you can literally go order this vest, not this particular vest in this style, but you can go get a vest from them with all the patches pre-made on it, and you're out the door ready to rock and roll. Well, you don't know how much work it was to get all of these. Now, I'm sure there's like 100 more patches. I just quit buying them because it was getting to be like even these two here. When Zach would drop these on the web page, he would do like a limited run of 1,000 of them. So you had to buy them as they were released over like a 1.5 year time period. So he'd do the Doom Crew patch, and yeah, so you had to be there like on a Friday night at 7:30, and at 7:35 they'd be sold out. You'd be ready to go. Even for the actual rockers, top and bottom rockers. Okay, I'm a huge Black Label fan. Now, Black Label don't come here no more. The concert venue that they used to play at, he got in a piss and match with one of the promoter managers or whatever and proceeded to trash the entire venue. You don't come back here no more. Just saying. Well, my customer knew that this was true, and he goes, "Did you happen to look through the entire envelope that was attached?" And I said, "No." So first I pulled the note out and went, "Damn it, you're right, dude, I'm an idiot. Yo." And then out fell this guitar pick. This is a Zakk Wylde guitar pick from when he went and saw Black Label Society about 8-9 years ago. Him and his kids. And those of you guys that don't know who Black Label Society and who Zakk Wylde is, he was the guitarist for Ozzy for a long, long time, and struck out on his own. And he's one of the bands that's managed by Sharon Osbourne. He's got songs like Suicide Messiah and a couple others that I thought were really kind of neat. And then I started following along with the Doom Crew idea and sucked down the rabbit hole. So he went to this concert, and as Zakk Wylde's playing the show, he's taking and he's playing his guitar and he's flicking these out in the crowd. Well, after the show ended, the floor was black and white tile. And so he walked around after the show and he found 3 of these picks just laying on the floor on top of the black tile. Nobody was thinking to look down, because it was dark inside a concert hall. So my guy here, Mr. D, was cool enough to share with me one of his Black Label picks, which I thought was awesome. And the moral of the story is, halfway through this video now, pay effing attention, BBI. Slow down. Look at everything everybody sends you. Now, what I could not believe in my mind is this guy was so totally calm about this. He's like, "Well, if it's too big of a hassle, just leave it the way it is. I'll take it the way it is." Either I got the coolest customers on the face of the earth, or this guy just happens to be the most relaxed dude on earth. I've been like, "Dude, screw you, fix it, make it the way I want it." I was like, "No, man, we're going to get this done." So, long story short, short story long, now you guys are all up to speed. BBI's not perfect, none of us are. And let's take the driver's section out. We're going to remove this variable, and this variable's got a hole in it too. It when you turn the knob, it feels like it's full of sandpaper. It's like, so this was going to get replaced anyhow. This will come out, this will come out, this coax is going to get removed. This is going to go. I'm going to rip it all apart, put it back together again. Yay! This is the pile of solder flick I dug out of the box from the previous owner. These are all the 100 ohm flybacks. There's the parts that's left over from the 2-pill rebuild. There's the case screws and all this other remaining jazz. Remove the variable. Now let's come over here and take a look at the final product. So now we have 10 Toshibas. 10 Toshibas. Fire, lightning, thunder, the count. This thing's gonna work. I might end up adding a blow it out with the air compressor here before I'm done. I might end up adding a capacitance tube, like somewhere in here for the input tune. I know this inductor is going to be way too freaking long. This is the 8-pill inductor. I might end up changing this out as well, but we'll see how it goes in testing. Pretty straightforward. Built new output combiner, new input splitter. Took this transformer and rewrapped it, this transformer rewrapped it, this transformer and rewrapped it, this transformer and rewrapped it. Changed the turns on this, added a capacitor here, removed a capacitor, removed a capacitor, added a capacitor, added a capacitor, added a transformer. Actually had the same metal clad cap available. We used RG316 on the inputs, changed this cap, this cap, this cap, this cap, this cap. Changed this choke, changed this, flipped this choke around, went ahead and added our racetrack. These are 150 puff metal clads within 1% on the output for each one of the output sections. They will never fail you. Went ahead and wrapped this. I managed to have the same gauge, size, and everything. Teflon. Used RG316 dual shield on the output, relocated our control wire so nothing ever crosses. That way we don't have to worry about it having any cross harmonics from the front to the back. And yeah, this only took 5.5 hours on a Sunday to get done because of my own lack of observation skills. Gotta love that. It happens. I was having a blonde moment yesterday, like all day long. I kind of feel like I'm having one today. But the upnote is, this thing is 99% done. I'm going in the house. I want to go spend some time with my family and not be out here, because I know I'm going to be out here tomorrow to finish this up, and then I immediately got to jump onto a whole bunch of competition boxes, because guess what? Break season is here, and the shootout season is coming upon us here pretty quick this fall. So I've got some shootout boxes I got to finish up here. Get them ready to go back east. That's this next week. Got a 250B box. I got a bunch of stuff coming up next week. So we're as far as we're going to get with this today. This is a healthy stopping point for me and all parties involved. We relocated the power wires, of course, split that up so we could load share the current. Yeah, we'll see you all tomorrow. We're finally at the tail end of the story. So come out this morning. I've been totally farting around with this thing. I finally got this to run the way I want it to. Clean, quiet, and smooth. And I don't know if I ever expressed to people what I mean by that, or if I explained what I mean by that. I want the amplifier to run, well, clean on the spectrum analyzer. And then also I've got a radio over here with a waterfall on it, and I want to see it with ambient emission. So what I mean is RF leaking out of the cabinet and out into the room. I'm going to pick that up with an antenna on the other side of the building over here. And I'm going to hear it, and I want to see it on the waterfall. So I want to see clean, okay? Spectrally clean. And I want quiet, as in like I don't want anything in here making noise. Transformer's not buzzing. Ferrite's not buzzing. Amp's not making any noise. Relay's not chattering. None of that shit. Quiet and smooth. I want to build power, and I don't want to see any excess heating in the combiner or in the splitter. None of that. I don't want to see any of that. Oh, you know, clean, quiet, smooth. Finally got that. I'm happy. I'm mentally okay with that. So this is where we're at. We're going to start out with a 2950. Let's put the amp in bypass. You know, I haven't checked the preamp and stuff on this yet, so we're going to do that next. 1000 watt slug and peak, 1000 in average, 5 watt slug and reverse. Back from the bird, 10,000 watt dummy load. Hello. Our nice little 20 watts of drive. And our 20 watts of drive is going to get us hello, about 800 watts of power. Spectrally clean. And over on the waterfall radio, spectrally clean. Here's the radio. Here's the amp. Turn our dead key up. And now we're at least generating some dead carrier. It's not all swing. Hello. It's about 800 peak watts. 20 watts of drive. Hello, hello, hello. Input tune, about a half a watt. Hello. Hello. Now, I know this guy's got a couple high-powered radios. Okay. So that's all we're going to drive it with. We're going to drive it with my 490, my 955. We're not going to push this thing to its max. The cost of the transistors says no, we should not. This thing is running tiddlywink smooth. I mean, it's as smooth could be. Ended up having to take all that inductor out. I ended up building a board for the input tuning coil. I ended up shorting this output capacitance way up. I mean, imagine that. We changed the entire load system of how this thing was tuned. Of course, we're going to have to add a bunch more capacitance to it. We didn't take anything out of the wire for length, so we didn't change our unit henries on our output tune. Awful bad. But on the input, we cleaned this all up, put this on a board so it's supported, trimmed back our input coax. This thing just basically took off and ran. It just took a little bit of time tweaking with it. So, yay. So far, the only thing in here other than the power supply that has worked. Everything else is broken. Okay. So, let's disconnect the 955. 955 off. Turn on the striker. The 2950. Let's disconnect the 2950, and we're going to hook up the 955. You idiot BBI. Pay attention, pay attention, pay attention. Okay. Turn the amp into bypass. Still same 1000 watt slug. Hello, audio. Put about 70 watts into it. Okay. Goodbye. Hello, audio off in the corner. Hello, audio off in the corner. Let's go, we'll flick that into the up position. So now we're reading 2x. And as we know, all of you guys that are returning fans, we know where to look to see the 1000 watt mark. But those of you all that are new and watching this for the very first time, this mark right here between the 40 and the 60, that 50 watt mark, that's 1000. Full deflection, otherwise the needle going all the way to the right, 2000 watts. Hello, audio. Hello, audio, 1, 2, 1, 2. Seeing 14 and some change out of it with 80 watts of drive, which isn't teabag. Let's come up here, let's look at the input tune. So I'm going to be able to pull this off from this current camera location. Let's see. Okay. It sets at about a 1.4, 1.56 maybe. This is our reflect actually in real world, half a watt. Now I got my dead key all the way up, so I'm putting like 5 watts of carrier in it. So watch what happens when we modulate. Hello, audio. We got our same about half watt worth of reflect up here on the bird meter, and this drops down to a 1.2. So it is what it is. It's good. It's good. In an ideal world, we're trying to get down to like absolute zero, but there's no such thing as an ideal realistic world. This is real world. Okay, let's take the 955 out of equation. Now I need my blue coax here. And let's bring the SR490 into it. There's a little bit more drive. But please note we don't have any air on this amp at all right now. None. And we're going to cover that here in this next segment. So, put the 10 pill in bypass. Let's zoom in here so you guys can actually see some digits, especially for you that are watching on phones. Hello. About 100 watts or so. No, wait a minute. Wait, oh. Gotta put the meter on 1X. Hello. Audio. About 180 watts. And go to 2X. Turn the amp on. Hello. Now, if I get anything past 2,500 watts, we're going to call this a win. Or even close to it with this level of drive. Now you, me, everybody that's involved in this game knows as a fact that you can put more power into this. I'd say probably no more than about 300. Just calling it, making it safe. And you're really going to want to monitor your exhaust air temperatures. So let's revalidate this test. Pinning it in the corner. 5X. So now we're reading that middle scale, and we're adding a couple zeros. The 50's 5, the 40's 4,000, 3,000, 20's 2, 10 is 1. Okay. Audio. 2,400 peak. And it will do more. And the input tune is freaking awesome. Hello. Let's go look at that. Hello. Audio. It's happy. Everything's happy. So, the reason we say 10 pill 2,500 watts, in my opinion, the only reason you'd ever want to build up a 10 pill linear like this is because you've got a bunch of like 200 watt radios. Let's do a little theory class. Every one of these 2 pill sections roughly does about 500 watts, maxed out. So 5, 5, 5, 5, 5. 5 times 5, 25. Put a couple zeros on it. That's what you're going to get for power out of it. In theory. There is almost a zero measurable difference in somebody's receive between an 8 pill and a 10 pill. Zero. There's not enough signal gain for it to be represented as a full S unit or even part of an S unit. Okay, for you to increase past that 2,000 watt range in somebody's receive significantly, we'd have to go to a 16 pill for there to be an S unit-ish worth of gain. So when you go to a 16 pill, you hit the land of 24. That's almost zero signal gain in somebody's receiver, roughly, from 16 to a 24. Now, there is a little bit more punch to it. This being said, I've had a customer here in town with a 24 pill in his semi that I just got done doing. I'm running around in my Suburban with a 16 pill, and I'm pointing at a guy in California. He's talking off the side of his truck, and he's keying on my ass. They're a little bit more punch, but when we went back and we looked at the video gate, zero difference in signal. Okay. As far as this is concerned, adding those 2 extra transistors just means more parts with like another 500 watts to the equation. This probably did 2,300 watts as a 2x8 because we were driving the snot out of those 8 transistors. Just something to think about. It's called the gain scale. And you reach a point of diminishing returns. I'm there now. With my setup I have now, for me to make a significant difference, Okay, 10,000 bird modulating to 35,000 or 40,000 bird, because I run it like a 15. For me to make a significant difference, I'd have to triple down on what I already have. So I'd have to go to like 315s. Or in my case, I would just go to 240s, but that would be like having the 40,000s, like having basically 420s. If you can get enough energy to the tube. So that would be like having 820s, okay, inside the deck. It is what it is. It's diminishing. You'll make better gain at the antenna by optimizing your antenna and putting a couple more elements on your antenna than you ever would with the amplifier. So, but this is perfect for the guy. This amplifier is the perfect thing for the guy that's got like the N2 and a 490 and a 955, and he just wants to cruise it all goddamn day. And he doesn't care, he wants to be able to put 150 watts, 200 watts worth of drive in the amp. And he's not worried about killing it, because this amplifier will take it. So take 350-ish watts worth of drive, and it's going to make almost 3,000 watts of power. But remember, you're not on a switch mode power supply. You're on an iron core supply. This thing sits at 20 volts, and when you modulate it, it drops down to about 16 and a half. Okay. And I've been playing with this a lot. These cores are kind of warm. You're pushing the transistors pretty hard. So the guy that comes up to you and says, "Hey man, I got one of them. I got a buddy of mine that's got one of them goddamn, and he does it this way, and he gets 500 more watts out of it." Cool. Do you want to risk your $250 a piece transistors? That's on you. So don't come back to me when your buddy says hook it up and run it this way, and I'm telling you to run it another way. You hook it up and run it, and the thing melts down. Just saying. Just saying. Okay, let's do fans. I don't know what you got on the corner of your cabinet, man. I don't know if it's road tar or paint or some fun happiness that come out of. I want to make a dirty joke right now, but I probably shouldn't. Happiness that come out of your partner in crime in life and it's decided to sit here and mutate. We don't know. Yep, Joy Juice. I remember when I was a kid, when I was in my 18 and 20th years in life, everybody was all about X-Force here. And there's a guy here, his name was Mr. Fix-It. Tom Brown was his name. Just an old hippie. He was into radio, man. Good cat. He had something like this sitting up on his shelf. Just sitting there chilling. So, oh, it's there, just if I need it. I don't need to use that. Everybody hear me just fine. I remember thinking when I was a young man, good Lord, I'm going to get like that. I'm going to have me a kick-ass base station just like that someday. Yeah. And I had to stretch out my metachlorines, as they would say in the world of Star Wars. And we set our goals higher. Okay, so let's brighten this up a little bit. Scrub the markers for the variable power here. Let's make these disappear. Okay. Well, that's that. We cannot turn the fan down anymore. That was the last hunk of the note. Because he wanted me to slow the fans down. If you slow the fans down, you're going to have an overheat issue. You're going to forget to turn the fans back up. And now that we've changed the baffling on the inside of the box, the thing is really quiet anyhow. I don't want to mess with the fans. Done. All the fans work. Amp runs well. But oh, audio got down. But oh, 1, 2. But oh, 1, 2. I'm gonna call this a win for the good guys. Honestly. Yep. On that note, I'm out of here, my man. I'm gonna throw the rest of the screws in this thing. I'm gonna give you a call on the phone. We're gonna sit down. We're gonna have ourselves a little bit of a chat, and you're off to the races and running. The amp's so nice, I had to rebuild it twice. I'll see you. Bye.